As you can see in these pictures of 5-club cascade juggling, there are moments in time when the clubs match up in an interesting way. This video is going to analyze why they line up, such that one is pointing up and the other down in each pair. If you look carefully at these pictures, you may notice that they don't seem to be perfectly vertical and matched up. Whether this is due to the math or my lack of ability to take screenshots, we will find out. Let's begin. In my other tutorial, we analyzed why, when you juggle odd number of objects, they line up all simultaneously. This video is going to take that concept and apply it to when you have 5 objects. First, let's label the objects 1 through 5 according to the order that they were thrown in. The first object to be caught was the first one to be thrown, which is that lower ball on the outside of the path. The second ball that was thrown, which is the second that will be caught, is the one that is higher up on the outside path on the left. We know that the objects will be in this paired up formation after n-1 big T all over n units of time after the first ball was released. This result can be seen in my other tutorial. Big T represents the period of the pattern, or how long a ball is in the air, and n is the number of objects. In this case, n is equal to 5. Now let's introduce a juggler to help us with this derivation. We start by giving him a juggling club. And to make this more interesting, let's say it's a torch. Or we can just light the club on fire. When someone is juggling 5 clubs, they release each club when it is approximately parallel to the ground. Let's call this angle 0 degrees or radians, whatever measure of angle you'd like to use. In ordinary 5-club juggling, each club spins 2 times, which is 4 pi radians. Now, since it spins 4 pi radians and the club is in the air for capital T units of time, omega, which is the angular velocity, is 4 pi over capital T radians per seconds, or units of time. We know that the time the first object has been in the air for is 4 capital T over 5 units of time. This is the measure of time that represents when all of the objects pair up. Let's put torches in the diagram, and the orientation is drawn in with yellow arrows. Remember that this diagram shows front view, so that torch 1 is going to point flame down when they intersect, and the handle will rotate into the picture and fall into the juggler's hand in the remaining time. By subtracting out the delay between when each club is thrown and the original time count of 4 big T over 5, we find out for how long each torch has been in the air. See the other tutorial for a more thorough explanation of where these numbers come from. As you can see in the diagram, torch 1 matches up with torch 4, and torch 3 matches up with torch 2. So now we have torches spinning at constant angular velocity for these periods of time. Let us compare the respective angles that result. We know that T1 corresponds with T4 and T2 corresponds with T3. And we also know that the angle swept out by an object spinning at constant angular velocity is given by the equation theta equals omega t. To find the angle displacement of the first torch, we plug in 4 pi over capital T for omega and 4 capital T over 5 for time. We simplify this expression and see that the club has displaced an angle of 16 pi over 5 radians, which is equal to 6 pi over 5 radians if we take out 2 pi. We also do the same calculation for the fourth torch and see that it has swept out an angle of 4 pi over 5. We do the same calculation for the second and third torches, which displace angles of 12 pi over 5 radians and 8 pi over 5 radians respectively. So now that we have an angle associated with each torch, let's see what it all means. If you recall our original juggler, you remember that when the torch leaves the hand when it is parallel to the ground, we called that angle of 0 radians. These are what the angles actually look like. Remember that torch 1 and torch 4 that I have drawn here represent the lower pair of torches. And here we have the angles of torches 2 and 3. Now, let's compare our results with a screenshot of Jongle Juggling Simulator. From the front view, it is kind of dazzling how the clubs seem to line up so nearly perfectly. But here is a side view that I did not show you before. Remember how I pointed out that the clubs aren't perfectly vertical? The math shows this, and my ability to take screenshots is redeemed. The clubs are not perfectly vertical, as we predicted. If you look very carefully, you will see that our answer is actually a bit off. The lower pair should be pointing towards the juggler, while the top pair should be pointing away, according to our predictions. Before you throw your mental tomatoes at me, let's analyze this. One thing to consider is that saying the club is thrown parallel to the ground is just an approximation for this jongle simulator. The main issue, however, is that we did not take into account dwell beats. In theory, the catch and the following throw of a club is a single standalone beat. However, in reality and in jongle simulator, the beats overlap. The site swap diagram, therefore, should show beats overlapping rather than summarizing them as dots, as shown in the bottom left here. Taking this into account, our numbers for period and angular velocity will be slightly off. However, this video's derivation gives a rough explanation for the lining up effect for 5 clubs. This effect is most noticeable with 5 clubs, though there is some pattern for any number of clubs.